Okay, so in this video we're going to start to develop some of our new algebraic techniques that we need. And in the previous video we looked at what is a polynomial, what do they look like, and then we did some manipulation of them. We added them together, we subtracted them, we multiplied them by numbers, we multiplied them with each other. What we didn't do was divide polynomials, and that's because we need some new algebraic techniques to be able to do that. So before we learn how to divide polynomials, which is potentially quite complex, we need to actually revise how we go about dividing numbers. Okay, it's really important that we understand that process so that we can then extend that out to the polynomials. And we're going to use a process of long division when we divide polynomials. And so we're going to refresh our memories on long division. Now, long division isn't really necessary when we work with numbers. And most of us, when we learn to divide in primary school, we learn short division. Short and long division are actually the same process. You just write down less information when you do short division. You do more of it in your head, you just don't write down the steps as much. So I'm going to do this division here. Well, actually, before we get on to that division, let's just talk about some terminology when we do a division. So if we divide 40 by 3, for example, 40 divided by 3, 40 is called the dividend. So the thing that we're dividing into is the dividend, and the thing that we're dividing by, in this case 3, is called the divisor. When we do that division, we can end up with, so for example, 40 doesn't divide into 3 a whole number of times, but it does go, 3 doesn't divide into 40 a whole number of times, but it does go into 40 13 times whole, okay, and that's called the quotient. It goes in 13 times whole and leaves a remainder of 1. Okay, and when we write that remainder, we don't write, when you first learn to divide, when you're back in primary school, you do write 40 divided by 3 equals 13 with a remainder of 1. But then when we learn about fractions, we learn how to represent that 1. And that's actually the same as 13 and 1/3, where the denominator of that fraction is the same as the divisor. Okay, so let's practice a division, okay, with some bigger numbers than 40 and 3. Let's refresh our memories with the process of short division, which I think will come back to you fairly efficiently. And then I'm going to extend that out to long division, and I'm going to show you that that's exactly the same process, we just write down more steps. Now, when we're dividing something that's complicated like a polynomial, we need to use long division because we need to write down more steps. We can't carry all the information in our head from step to step like we can when they're numbers. Okay, right, so we're going to do this same division twice. So when we divide, we always write the divisor outside of this symbol. I don't really know what that's called, to be honest. 4,392. Okay, and then we go through a number of steps. Now, often we skip the first few steps in terms of what we write down, but technically what we do is we say, okay, how many times does 19 divide into 4? Okay, and 19 doesn't go into 4 at all. And so we have a remainder of 4. It goes into 4 0 times and leaves a remainder of 4. So that we carry the remainder over into the next column. And then we're looking at how many times does 19 go into 43. Now 19 goes into 43 twice whole. The quotient is 2. Okay, so that goes at the top. So it goes 2 times into 43, and then we need to work out again what the remainder is. Okay, so 19 times 2 is 38, which means the remainder when we divide into 43 is 5. So that 5 gets carried over into the next column. How many times does 19 go into 59? I suspect it goes 3 times into 59. 3 19s are 57. So it goes 3 times and leaves a remainder of 2. We carry that 2 over into the next column. And then it's how many times does 19 go into 22? Well, it goes once, and we clearly have a remainder of 3. So therefore, 4392 divided by 19 is 231, and we have a remainder of 3, which we write as 3/19. Okay, the remainder divided by the divisor, which in this case is 19. So it's 231 and 3/19. Okay, let's do that as a long division process, which, as I said, is exactly the same. We're going to do all the same maths we just did in our head. We're just going to write a bit more of it down on the paper. Okay. Alright, so we're going to have 19. Sorry, let me just move that down a little. We're going to have 19, 4, 3, 9, 2. Okay, Again, the first step is a bit trivial because it's how many times does 19 go into 4? It doesn't. We're going to skip over that step, which is what we often do with short division as well, and we just go straight away. Well, it doesn't go into 4, so let's straight away think about 43. Okay. So how many times does 19 go into 43? We've already done that thinking previously. We know that it goes twice. We write the 2 up the top. So everything's the same up until now. The difference is that we don't do the remainder calculation in our head. We write it out explicitly. So what I'm now going to do is I'm going to do 2 times 19, which is 38, and I'm going to write that underneath. Okay. So I've done 2 times 19, that's 38, and I write that underneath here. And then what I do is I subtract. Okay, so 43 minus 38 is 5. So all we're doing in this process, we're writing it out more, but all we're doing is working out that 5 that we did in our head, the remainder. Okay, and the remainder we work out by doing 2 times 19. Okay, so we've worked out that 19 goes into 43 2 whole times because 2 times 19 is 38, and the remainder therefore will be 43 take away 38. Okay, we did all that in our head before, this time we're just writing it out. Okay, then what we do is, I'm just going to remove those arrows so it doesn't all get very confusing. Then we bring down the next term in our number, and we now focus on 59, which is what we did over here. We focused on 59. How many times does 19 go into 59? Okay, we know it goes 3 times into 59, and then we do 3 times 19, which is 57, and we write that down underneath. And we subtract 59 minus 57 is 2. And that's how we get our remainder, which we calculated over here before. We just did it in our head without writing out the steps. Okay, and then we repeat, we bring the 2 down. How many times does 19 go into 22? It goes once. Okay, we do 1 times 19, and we write that down the bottom here, and then we subtract, and there's our remainder. Okay. So there's our quotient up here and our remainder down the bottom. So the answer therefore is the same as what we got before. It's equal to 231, that's the quotient, and a remainder of 3, which means 3/19, the remainder divided by the divisor. Okay, so we now want to follow through this process using polynomials. Okay, so this is a process which might seem a little tricky initially, but I guarantee you it is just about practice. You'll all be expert polynomial dividers before too long. Okay, so we're doing a cubic, 3x cubed minus 7x squared plus 2x plus 4 divided by a linear function, x minus 3. So we're going to write it out like we did up here with this, again, I don't know what that symbol is called. So we're writing out x minus 3, and we're dividing that into 3x cubed minus 7x squared plus 2x plus 4. Okay, so then the process is similar. We switch around how we think about things a little bit, okay? So what we want to do is, remember up with the numbers, I'm going to try and keep this here for a bit so I can see it. The first thing we did was, we looked at 19 doesn't go into 4, we ignored that. We looked at how many times does 19 go into 43, okay? The other way you could think about that, just because it's going to be easier to do it with the algebra, is if the question is, how many times does 19 divide into 43? The same question to that is, what do I need to multiply 19 by to get 43? Okay. Now, with the polynomials, we're not going to be trying to work out how many times does x minus 3 go into 3x cubed, because that's going to get very complicated. We're just going to focus on how many times does x go into 3x cubed. Okay, all the other things will work out in the wash as we calculate our remainders. Okay, so the question is, how many times does x go into 3x cubed? Or an easier way to think about that when you're working with algebraic terms is, what do I need to multiply x by to get 3x cubed? Okay, and that's 3x squared. And that's the beginning, that's the first number in our quotient. So 3x squared. Now, it's really important when you're doing these divisions, and we'll see some other examples as we work through this video, that we keep things lined up. So I'm going to have x cubed terms, I'm going to have x squared terms, I'm going to have x terms, and I'm going to have constant terms. Okay, and that will make sure that I'm subtracting like terms. Otherwise, I'm going to find myself in trouble. Okay. All right. So then remember the next step. Once we wrote something up the top here, once we wrote this 2 up here, sorry, So once you're at this 2 up here, what we then did to work out the remainder was we did 2 times 19, and we wrote it underneath here, and then we subtracted. And we're going to do exactly the same thing with the polynomials. Okay, we're going to do 3x squared multiplied by, not just by x, sorry, we're going to do 3x squared multiplied by x minus 3, and we're going to write that down underneath. Okay, so 3x squared times x minus 3 is 3x cubed, minus 3 times 3x squared is minus 9x squared. Okay, now the whole point of this is that these terms should be the same. That's how you picked. You worked out what would I have to multiply x by to make it the same as 3x cubed. Okay, if those two terms there aren't the same, you put the wrong thing up the top, or you did your multiplication wrong. Okay, because the next thing we do is subtract, and it's really important that those terms eliminate. 3x cubed minus 3x cubed is 0. Negative 7x squared minus 7x squared, negative 7x squared minus negative 9x squared. So that's negative 7x squared plus 9x squared. So please be careful with the subtracting negatives. Okay, so you've got negative 7 minus negative 9 is negative 7 plus 9, which is positive 2. I'm sorry if you can hear some noise in the background. I'm in headphones, so hopefully you can't, but my washing machine is finishing up and it's going a little crazy. Anyway, so we subtract, and then you'll remember once we did that, so we did our 2 minus 19, that gave us 38, and we subtracted, and then we got 59. We got 5 when we subtracted, and then what we did was we brought down the next term to get 59. And we're going to do the same thing here. We've now got 2x squared. We're going to bring down the next term, which is plus 2x, and we're going to repeat the same process again. Okay, so the question is, what do I need to multiply x by to get 2x squared? It's really 2x squared divided by x gives what? But I find it easier with the algebraic terms to think about what would I need to multiply x by to get 2x squared? And that would be 2x. So that's the next term in my answer. Okay, then I'm going to take that term, multiply by x minus 3, and write that down underneath. This is about working out the remainder. Okay, 2x times x is 2x squared. They should be the same, so I'm happy. I've picked the right thing up the top. 2x times negative 3 is minus 6x. And now we subtract. Okay, so 2x squared minus 2x squared, they should give you 0. That's the point. 2x minus minus 6x is 2x plus 6x. That's 8x. Then we bring down our next term, and we repeat the process again. Okay, so this time it is, what do I have to multiply x by to get 8x? And that would be plus 8. That's the next term in my quotient. Then I'm multiplying 8 by x minus 3 and writing that down underneath. 8x, I'm happy, they're the same. That should be how it works. They cancel out. 8x minus 3 times 8, so minus 24. And then we subtract. 8x minus 8x, they should cancel out. 4 minus minus 24, 4 plus 24 is 28. Okay, so in terms of now answering our question, okay, we've done this division. So 3x cubed minus 7x squared plus 2x plus 4 divided by x minus 3 is equal to the quotient, okay, which is this. So it's equal to 3x squared plus 2x plus 8. And then we have our remainder, which is this, divided by our divisor, which is this. So plus 28 divided by x minus 3. And that's exactly the same as what happened up here with the numbers. Our answer was 231 plus 3 over 19. 231 and 3/19. Okay. So quotient plus remainder over divisor. Okay, let's have a look at another one. We're going to have this written in a slightly different form. It's just going to be how we go about giving our final answer. Okay, but we'll worry about that at the end. At its core, it's still about dividing a polynomial. Divide p of x, which is 4x cubed minus 8x squared plus 3x minus 1, by 2x plus 1. And hence, let's worry about the and hence once we've done the division. Okay, so we're going to divide 2x plus 1 is the divisor, dividing that into 4x cubed minus 8x squared plus 3x minus 1, which is the dividend. Okay, process. What do I have to multiply 2x by to get 4x cubed? So that would be 2x squared. We can check that because what we're next going to do is 2x squared times 2x plus 1, which gives us, 2 times 2 is 4x times x squared is x cubed. Good, we know we're right. And then plus 1 times 2x squared, so plus 2x squared. Then we subtract. 4x cubed minus 4x cubed, they should cancel out, they do. Negative 8x squared minus 2x squared is negative 10x squared. The errors you'll make here will be in the subtractions. Okay, be careful. Say them out loud if you need to. Negative 8 minus 2 is negative 10. And then we bring down our next term, plus 3x, and we repeat the process again. Okay, so now it is, what do I have to multiply 2x by to get negative 10x squared? So that would be minus 5x, and again we can check that now because we're going to do minus 5x times 2x plus 1, okay, which is minus 10x squared. So minus 5x times 2x is minus 10x squared, minus 5x times 1 is minus 5x. And then we're going to subtract, 10x squareds cancel out, plus 3x minus minus 5x, okay, so minus minus 5x is plus 5x, so it's 3x plus 5x, which is 8x. Okay, bring down our next term, minus 1, and repeat the process again. Okay, what would I need to multiply 2x by to get 8x? So that's going to be plus 4, that's the next part of my quotient. Okay, then we do 4 times 2x plus 1, and we write it down the bottom here. So we're going to get 8x, good, we know we're on the right track, and plus 4 times 1, so plus 4. And then we subtract, 8x minus 8x is 0, negative 1 minus 4 is negative 5. Okay, so we have our quotient up here, and we have our remainder here. Okay, so this is our quotient, and this is our remainder. Okay, so let's focus on, so we wanted to divide p of x by 2x plus 1, so we've just done that. So we've done p of x divided by 2x plus 1, and we found that we got 2x squared minus 5x plus 4, the quotient, plus the remainder, which is minus 5, so it's going to be minus 5 on the divisor, which was 2x plus 1. You could write plus negative 5 on 2x plus 1, but it's nicer to write this. If you're adding a negative, you're subtracting. Okay, so that's our answer, but now let's go on to the hence part of the question. So hence write p of x in the form 2x plus 1 times q of x plus r, where q of x is a polynomial and r is the remainder. Okay, so what we actually want to do here is we just want to take this answer one step further to write our answer in a different way. We're going to multiply both sides of the equation by 2x plus 1. Okay, so when we multiply the left-hand side of the equation by 2x plus 1, that's simply going to cancel that out. P of x divided by 2x plus 1 and then times by 2x plus 1 gets rid of that from there. That's how we're going to get p of x on its own, by multiplying everything by 2x plus 1. Then we're going to multiply the quotient by 2x plus 1. Sorry, minus 5x. So I might write it at the front actually. 2x plus 1. 2x squared minus 5x plus 4. And then when we multiply this by 2x plus 1, we're just going to get minus 5. And so there we have done what the question said, which was to write p of x as 2x plus 1 times q of x, where q is a polynomial, that's a polynomial, it's a quadratic, plus the remainder, where the remainder is negative 5, so minus 5. Okay, so we've written it in this form. Now, if you're asked to do a division, divide this by this, that would be your answer to the division, okay? But we can take that information we've learnt from the division to rewrite p of x in a different way. And this becomes important when we get on to trying to factorise our cubic and quartic and higher degree polynomials down the track, okay? Alright, so complete the following polynomial division. So here we're just asked to do a division. We would simply just give the answer that what does this division actually equal. Okay, so we wouldn't then manipulate it. Okay, so again, let's practice this again. Can I suggest that you pause the video here and have a go at doing this one yourself, and then come back and watch me talk the way through it and check that you've done it correctly. Okay. Alright, so hopefully you've been away and had a go at this one yourself, and let's check through your answer. So we're dividing x minus 2 into 3x cubed minus 2x squared minus 4x minus 3. Okay, first step. What do we need to multiply x by to get 3x cubed? That would be 3x squared, and that's going to go up the top in my x squared column. Then I do 3x squared multiplied by x minus 2, and I write that underneath. So we're going to get 3x cubed minus 6x squared. Okay, great. And then we subtract. 3x cubed cancel out. Negative 2x squared minus 6x squared is negative 2x squared plus 6x squared, so that's positive 4x squared. And then we bring down our next term, which is negative 4x. Okay, and we repeat. What would we need to multiply x by to get 4x squared? So that would be plus 4x, okay? And then we're going to now multiply positive 4x by x minus 2 and write that underneath. So we get 4x squared minus 8x. Good, we're happy with that. So now we can subtract. The 4x squareds cancel out. We have negative 4x minus 8x. So it's negative 4x plus 8x. So that's positive 4x. We bring down our next term and we repeat. What do I need to multiply x by to get 4x? That would be plus 4. Then we multiply 4 times x minus 2, and we're going to get 4x minus 8. And then we subtract. 4x minus 4x is 0x. Negative 3 minus 8 is negative 3 plus 8, and so it'll be positive 5. So then, going back up to what does our division equal? When we divide the cubic by the linear function, we get the quotient, which is quadratic, 3x squared plus 4x plus 4, and then plus the remainder, which is 5 in this case, divided by the divisor, which is x minus 2. Okay. Yes, we could then multiply everything by x minus 2 and find out what this cubic is equal to, but that's not what the question's asking us to do. It's not asking us what does the cubic equal, it's asking us what does this division equal, okay, which is this. Okay, example 4. This is our last one. Divide this by this. There's a couple of issues here we're going to need to look at, and express in the form dividend equals divisor times quotient plus remainder. Okay, so this is essentially asking us to write it in the same answer that we did up here. So this is dividend, divisor, quotient, remainder. Okay? So that's exactly what we want to do. Alright. So let's divide by x minus 1. Now there's a number of things we need to look at here in the division. So we're dividing by x minus 1. X minus 1 is the divisor. Now the dividend is a cubic. It's really important that you write your terms in decreasing powers of x and in order. So this must be x cubed. If x cubed is your highest power, it needs to go there. Okay? So make sure that you write the terms correctly. So it's actually negative x cubed. Then we need our x squared term, which is plus x squared. And then we need our x term, and there isn't an x here. And it's really important that if there's a missing term in the polynomial, you add in a 0x. Otherwise, when you come to doing your subtractions further down, you won't be subtracting like terms. So it is still about making sure that if it's a degree 3 polynomial, the dividend, there should be a column for the powers of 3, column for the powers of 2, column for the x terms, and a column for the constants. Okay? And if any of those are missing, then you include a 0. And I like to include a 0x so I can keep track of those like terms. And then we've got our constant is plus 5. Okay? Alright, otherwise the process is the same. What do we need to multiply x by to get negative x cubed? That would be negative x squared. We're going to multiply negative x squared by x minus 1 to get negative x cubed negative x squared times negative 1 is positive x squared. Okay, now this is going to bring up a couple of issues here because we're going to see something interesting happen at this step. So now when we do our subtraction, negative x cubed minus negative x cubed, they cancel out, that's what we expect. But we've also got x squared minus x squared. They've also cancelled out. Now again, continue to follow the process, okay? I'm going to write this as 0x squared, okay? Continue to follow all the steps. It feels very trivial while you're working your way through the moment where there's a whole lot of zeros, but just continue to follow the process because we have to keep going so we can deal with this 5 down the track. You can't just stop at this moment, okay? Alright, so then the process is the same. We bring down the next term, which is also plus 0x, and we start again. What would I need to multiply x by to get 0x squared? Well, that would be 0x, okay? 0x times that is going to give me 0 lots of x squared plus 0 lots of x. Okay, so very trivial here, and I know it seems like, what am I doing? What's happening here? That's okay, we have to keep going. Subtracting 0x squared minus 0x squared, they cancel out. 0x minus 0x, they're also 0, but I'm going to write 0x here so I can continue to think through the next step. Okay. And then the next step is, what do I multiply x by to get 0x plus 0 on the end here? Still again, 0 times all of this, so that's going to be 0 lots of x plus 0, and then we subtract, because we need to get to that point where we can work with the 5, whether it becomes our remainder or gets to work in with some other terms later on. So we've got our remainder, we've got our quotient, we've got our dividend, and we've got our divisor. Okay, so we know that the dividend, which is, let's write it a bit more neatly again, let's write it back how it was, so it's x squared minus x cubed plus 5. The dividend is equal to the, well, I'm going to write out, I'm going to get to that answer first. So we did that divided by x minus 1, and we found that it's equal to our quotient, and our quotient is just negative x squared, okay, plus the remainder, which is 5, over the dividend, which is x minus 1. And again, if we were to multiply everything in this equation by x minus 1, okay, we're going to have x squared minus x cubed plus 5 equals x minus 1 times negative x squared plus 5. And so what we have here is dividend multiplied by equals divisor multiplied by quotient plus remainder. Okay, dividend, sorry. So all we're doing from this step to this step is we're multiplying everything by x minus 1. It gets rid of it from there, it gets rid of it from there, and we multiply that by x minus 1. Okay. Alright, I want you to stay focused on the process of division though, okay, and then obviously secondary to that is the form that the question wants you to write the answer in. Okay, practice today is again an exercise from your textbook, exercise 10F. That's the list of questions that I would like you to do.